In this problem, we'll look at a system of equations in which some of the coefficients are not known. We're asked to find the numbers c and d such that negative 2, 3 is a solution of the system cx minus 4y equals 7, 3x plus dy equals 8. The key to this is to note that this ordered pair, negative 2, 3, is a solution of the system, which means it makes this equation true and it makes this equation true. So I can substitute negative 2 for x and 3 for y. When I do that, I will be left in the first equation with only the variable c, which I can solve for. When I do that in the second equation, I'll be left with only the variable d. So let's begin over here with cx minus 4y equals 7. Since this is a solution of the system, I can write c times negative 2, substituting negative 2 for x, minus 4 times 3, substituting 3 for y, equals 7. Multiplying, I get negative 2c minus 12 equals 7. Adding 12 to both sides, I get negative 2c equals 19. Dividing both sides by negative 2, I get c equals negative 19 halves. And I found the number c. Do the same thing for d, or something similar. I have 3x plus dy equals 8. I substitute negative 2 for x, 3 times negative 2, plus, and I substitute 3 for y, d times 3 equals 8. Simplifying, I get negative 6 plus 3d equals 8. Adding 6 to both sides, I get 3d equals 14. And dividing both sides by 3, I get d equals 14 thirds. So I found c and I found d, and that's the solution of the problem, because I was asked to find the numbers c and d.